At our core, we offer an open and governed platform which makes the intelligent data platform the natural choice for ISV partners to build on top and deliver a seamless first-party Azure experience. That's why I'm so excited about our powerful partner ecosystem to bring the intelligent data platform to life for our customers. Thanks to partner solutions that span across every layer of the intelligent data platform, a wide range of customers get the seamless and cost-optimized experience that meets their specific needs and scenarios. Let's dig into the first component of the intelligent data platform, our operational databases. With Azure operational databases, you have choices. Choose your favorite technologies, and Azure has you covered with an incredibly comprehensive portfolio of operational databases, including relational, non-relational, and open source. Azure supports a range of deployment options, popular stacks and languages, and a comprehensive set of data engines. Let's start by taking a closer look at Azure Cosmos DB, our fast and scalable distributed database for cloud-native applications. Cosmos DB offers speed, performance, and flexibility, along with enterprise-grade features and security accessible to every application, regardless of size or scale. It is relied upon by industry-leading enterprise customers and digital native startups to run their mission-critical applications. But how does Azure Cosmos DB integrate with the broader Microsoft Cloud? We are building the capability for citizen developers to use Power Automate with Azure Cosmos DB or Azure SQL DB to unlock real-time customer data. For example, if you create an application that takes an order, tracks it, and helps fulfill the order, then managing inventory can be simplified. You can set it up to notify warehouse workers when an item is in short supply and needs to be reordered. Best of all, this can be done with almost zero code. We're enhancing open source database support with another general availability release. Azure Cosmos DB is expanding beyond NoSQL and now supports distributed PostgreSQL. SQL programming model and support for Postgres extensions. After becoming available last month, we're already seeing more than 35% increase in customers for this new offering. When it comes to data engines, Microsoft SQL Server is not only a leader in the space, we've also worked to bring SQL from the cloud to the edge. In Azure specifically, we've invested to ensure that it's truly the best place for SQL workloads, providing flexible options for application migration, modernization, and development. As you can see, we've come a long way since SQL 6.0. SQL Server has a strong history of innovation built upon addressing the needs of our customers. These days, our goal is to help you do more with the same SQL tools and languages you already know. As you can imagine, we've been hard at work iterating on SQL Server 2022, which is why I'm really excited about the recent general availability of SQL Server 2022. We announced it just a few short weeks ago, and already there are over 175,000 instances of SQL Server 2022 deployed. Wow! There is so much goodness packed into this new release, so let's take a closer look at what makes SQL Server 2022 stand out. It all starts with connecting SQL Server to Azure. SQL Server 2022 is now a truly hybrid data platform. It's using Azure SQL Managed Instance for managed disaster recovery. It's using Azure Synapse for near real-time analytics. Or you can integrate with Microsoft Purview for insights, lineage, centralized policy management, a true hub for security. SQL Server now connects to Azure on your terms in ways never seen before. We know that security is always critical for data. So not only does SQL Server continue to be the least vulnerable database in the industry, it also brings innovative data protection capabilities like SQL Ledger, which performs blockchain inside the SQL Server engine. It collects a detailed history of all modifications and stores it in a tamper-evident ledger inside the SQL Server engine. This protects data from any attacker or high-privileged user, even database administrators. All of this value with no expense to performance. Our record-breaking benchmarks prove we are still the leader in price performance. The engine adapts to your workload, giving you faster performance with no code changes. In fact, TPC benchmarks released just last week show SQL Server 2022 as the #1 performer for non-clustered 1 terabyte and 3 terabyte workloads. Azure SQL Database also has some exciting new features, including the ability to develop and test databases locally and push data from SQL Engine with T-SQL to almost any REST endpoint. Streamlined data access is now possible with the Data API Builder, and the Azure Function integration includes SQL input and output bindings and support for .NET, Node.js, and Python. Pretty incredible, and in just a bit, Drew is going to demonstrate these capabilities. Now that we've covered databases, let's talk a little bit more about how the Intelligent Data Platform delivers value through deep integration with analytics. In order to make smart data decisions, we are encouraging customers to bring their data from across the hybrid multi-cloud and on-premises data estates into a lakehouse foundation. Data integration builds on a solid foundation using flexible compute modalities through Spark as well as SQL in Databricks. Once your data is in Azure Synapse, you can transform and prepare it for advanced analytics and machine learning workloads to gain actionable insights. And of course, the storage is optimized for high-scale compute with critical workloads such as building complex ML and AI models. Data governance is among the top priorities for chief data officers in every industry. They need help with security, compliance, and data management at big data scale. Let's talk about how we are helping them. Microsoft Purview is a unified data governance solution for operational databases, analytics, and machine learning and AI. The solution isn't just for data estates on the Intelligent Data Platform, but also for hybrid and multi-cloud data estates with built-in integrations for industry's leading data platforms and fabrics. The solution has only been in the marketplace for 1 year, and already 26% of the Fortune 500 companies are using it. The Microsoft Intelligent Data Platform brings all of your data together, fully integrating your databases, analytics, and data governance. This allows you to accelerate innovation in your organization and achieve agility across all your data. Now, knowing how the Microsoft Intelligent Data Platform works is good, but even better is seeing it in action. So now I'm going to hand it over to our Microsoft experts for some exciting demos. Thank you so much for listening today. I wish I could be there in person, but you're in great hands with Bob, Charles, Drew, and Buck. Take it away, Bob.
Well, thank you, Rohan. I appreciate that. Great message, Rohan, especially about the whole idea of putting this technology together as one suite of services. One of the innovative technologies that Rohan mentioned in his message to you was Azure Cosmos DB for Postgres. Let's go now talk and learn through example to see this in action. Let me invite on stage Charles Feddersen to show it to you. Charles?
Hey, Bob.
Thanks.
How are you? Good to be here. Hi, everybody. My name is Charles Feddersen. I lead the product management for Postgres on Azure. Today, I want to talk to you and show you about what we've done with Postgres in Cosmos DB. We announced this as a generally available feature at Ignite, and there's 4 things that I want to show you in the demo. The first, we'll just take a quick look at the provisioning experience and make you familiar with that. We'll then get into some basic development using the most common graphical tool for building Postgres solutions today. Then we'll expand that and show you how you can distribute data and benefit from the cluster scalability for running these operational workloads in Cosmos DB. And finally, something very specific, but one of the most common scenarios we see on the platform is tenant management for customers, ISVs, or enterprises who are building multi-tenant applications on the platform. So let's go ahead and get started. And here you can see I'm in the Azure portal. You can see actually that it's Cosmos DB, and I've got all of the existing NoSQL APIs that I'm used to. Here I can look at NoSQL and Mongo, and on the right I've got Postgres. We'll hit Create, and this will bring up the provisioning experience. Very simple. Subscriptions and resource groups. I'm going to give this a name, and then I'm going to pick the region. And then what I want to show you actually is how to configure this. So I'm going to click here, and immediately you can see that we've got a drop down, and if I expand this, you can see I can choose multiple nodes. This is the sign that it's a cluster. You can have up to 20 nodes, which is a soft limit. And so it enables you to this horizontal scalability of the workload. Now, we'll start small, and I'll go ahead and click Save on this. I'm going to go ahead and give this a password, and I'm going to need to type that twice. We can go ahead and review and create this, and then I won't click Create, but you can get the cluster started. So we've got a cluster now created in Cosmos DB. Let's now switch over to the development experience. And so in this scenario, I'm in PG Admin. You can see on the left, I've got the browser, and I can see everything I'm used to. I'm going to go ahead and create this table, set of basic data types. You can see here it's got a primary key. And I'm also going to go ahead and create a non-clustered index as well to show you that just works. Now, here's something new that we did at Ignite. You can see here that I've got a Postgres extension called Azure Storage. And I'm going to run the account list function here. And there's an account called CFMech. This is a blob storage account. And in this insert statement, you can see that I'm going to insert into the table I created, referencing that Postgres function. And so I've got the mech, I've got files, which is my container. And when I run this, it runs for about 5 or so seconds. And I'm going to load about 500,000 records into the database, right there. So this is a simple way to load. Now, if I highlight and run account star, no problem again, 500,000. Let's look at some of the compatibility. So we'll start with a common table expression. We'll highlight this and run it. It just works, as you'd expect. Let's go down and actually hit an extension. So here's tdigest percentile. I'll go highlight this one and run it. This just works as well. And then finally, I can show you the programmability elements as well. So I can go and create this function. That works. And now I can go and invoke the function, and that works as well. So a really familiar Postgres experience in Cosmos DB. However, I want to switch over now and show you how we can scale this data. So here, you can see I've got a basic setup of a command prompt, and I'm still in PG Admin. And if you take a look at this, I'm going to go and actually highlight a function here called getActiveWorkerNodes, which shows now my cluster has got 2 nodes. So I'm on a cluster. And I'll highlight Citus shards, and there's none, because my table is not distributed. We'll go highlight the count star again. This looks good. We've got the row count. And if I explain this, and we run this, take note of that workers plan 2. This is a non-distributed query. So I'm going to go start my app now, which is going to push a bunch of traffic onto the database. So that's running. We'll come back, and we'll run our row count again here to see what we've got. We'll go run that. We've got to run again. So the row count's incrementing. And now this is going to distribute my table across the cluster. That's running with no interruption to my workload. And so once this command goes ahead and finishes, hopefully pretty soon, I will have a distributed table. And so I can show you this now by running the Citus shards command again. And here I've got 32 rows. So now I've got a distributed table. I've got an increasing row count, as you can see here. But finally, if I go and explain this, you're going to see that now I've got 32 because it's a distributed query. And so if I switch over again now, I want to show you how I can isolate some of the rows to a dedicated node. Here, we're running. I've added another node. And you can see now that if I run Citus shards, I'm going to have 32 as I had before. The next query is going to use the tenant ID. The tenant ID exists in every table in this schema. And tenant ID 201 has got about 70,000 rows. It's disproportionately large, and that could be impacting my workload. So here you can see a function, isolate tenant, and I'm going to use the value 201. And this is going to break the shard apart and give tenant 201 its own shard. I'll go ahead and run this again, and I've got 34 shards. And that's because when I broke 201 apart, I broke everything above it and below it. So that's why there's 34 instead of 33. So now I can see the tenant ID there. And if I scroll across, I can see the size. That's definitely the large shard that I want to deal with. So I'm going to take that tenant ID and put it into this function. I'm also going to tell it the node I want to move from and to. So here I can see private C is the node that it's on at the moment. I'm going to move it to W2, which is my new node with no workers on it. That'll run. It's going to be relatively quick. And all of this has been happening with no interruption to the workload that I've been running. Super slick. So what I've shown here is the ability to start small with the applications that you're building, to scale them out onto the cluster, to handle tenant isolation in the system completely online. And this is really important for ISV and enterprise, where the cogs of these underlying platforms for building multi-tenant applications is really important. Cosmos DB for Postgres gives you first-class experience for benefiting from the efficiencies of bin packing multiple tenants onto a single node and putting large tenants onto their own dedicated node under a single connection string. We handle all of the routing to the associated tenants, and you don't need to make any changes to your app. So what are your thoughts, Bob?
Well, first of all, the PG admin was pretty cool. Like that feels like Postgres, right? So people that are Postgres developers will just love that experience. But Charles, I'm thinking out loud here. I'm like, cloud providers typically take almost like a year to make sure they're up to speed with like the latest version of Postgres.
Yeah.
Postgres 15 just came out, so how are you guys handling that?
Yeah, it's a great story. So we've got Postgres 15 in Cosmos DB already. It's generally available. We actually shipped it only a week after the community announced it. And we actually feel bad about this, Bob, because we know we can do it in under 24 hours, but unfortunately Postgres this year slipped to right in the middle of Ignite.
Okay, so sorry, Charles, you gotta do better next time, man.
It was a little risky.
That's
It was a
awesome.
little risky.
So Charles, how can anybody get this?
Yeah, so absolutely. So there's a free trial for Azure Cosmos DB for Postgres. It's available today. No subscriptions or credit cards required to get started. Just go to aka.ms/trycosmosdb, and it's there, and you can get started effectively immediately. It's all
Awesome.
there.
Thank you. Thanks.
Cheers.
Thanks, Charles. Appreciate it. Thank you. So Rohan talked about SQL Server 2022, a little bit of a passion of mine, that just became generally available. And certainly Rohan talked about the cloud capabilities that come for SQL Server to be connected to Azure. I'm kind of a performance person though. So one of the things that's really empowered about SQL Server 2022 is something called built-in query intelligence. The ability to get faster with no code changes and the ability to get deep insights into the engine for performance for developers. So what I'd like to do is show you first a demonstration of a feature that just comes built into the engine called DOP feedback. Now consider this scenario. I know some friends on the Power BI team like Patrick LeBlanc and Adam Saxton. They're pretty smart guys, but they're always calling me about performance problems with SQL Server. They're like, Bob, we have this problem. We're running this machine, we're running workload on a particular machine with SQL Server, we're running our reports, and we see this kind of like blip in performance, and we don't know how to figure out what the problem is. So let me show you a little bit what that actually looks like. So I like using perfmon to look at problems. So I went and looked at a perfmon chart that they have here, and what I've got is processor time that I'm looking at, and I'm looking at the green, which is a throughput, batch requests per second. So I'm looking at processor time along with batch requests per second, and I notice this blip in performance, like a dip in throughput at the same time that processor time really gets larger. Now, I know SQL pretty well, so I decided to track something called active parallel threads at the same time. This is telling me that there's probably parallelism kicking in, which is probably from a report, at the time that the workload has a drop in performance. And you can see it happens in a couple of different instances. This is like the blip in performance. So I decided to flip over into something called the query store. The query store giving me deep in performance information, and I found the query that is part of this problem. It's running in parallel, scanning an index. Looking deeper into the query store, I can find out it's using something called a DOP of 16, which means 16 threads are running at the same time to get this data. So I told the Power BI team, what are you setting DOP to, max DOP? They're like, what's max DOP? I don't know what to set this to. Can SQL Server just figure this out for us? I said, SQL 2022 can. If you set DB compat mode to 160, and you set an option called DOP feedback, the engine can monitor this query over time, and on a query-by-query basis, adjust the threads down. Now, this is something called extended events you're seeing right here. And it's showing the progress over time, whereas the query starts at 16 threads, and we staircase down this DOP value almost down to 4. But here's the thing, we have a do no harm policy. So if you notice here on the right-hand side, we're going to show you what is the adjusted elapsed duration of the query. It's not gotten slower. In fact, it's gotten a little faster. And the beauty is you can also see the average CPU time total for all the threads has gone down over time. This is what we call parallel efficiency, and the engine is figured out automatically. And in fact, you can see from a report here, the average duration as we lower this DOP down has come to what we call a stabilization point. And what's really beautiful is to look at CPU utilization. Automatically, engine has to lower the amount of CPU for this workload, running the report at the same time and the same duration. So I flip back over here and I look at something called query store plan feedback. We persist this telemetry, this feedback, inside the query store of the database, inner user database. So now it runs at any point in time, even if the server restarts. So we went back and ran perfmon again. Look at this beautiful graph. You can see the throughput remains constant, and the amount of processor time is far lower than before. The Power BI guys are pretty happy now because they can still run their reports on the same SQL server as their workload and achieve consistent performance with no code changes. So I was showing this to my friend Connor Cunningham, who is also an architect in the SQL team. He's like, Bob, that's pretty impressive. But what about that blocking problem they're running into? I'm like, hey, Connor, we don't have anything to solve the blocking problem. So he said, why don't you shift over to the machine that you have here? It's not very secure, so I kind of connected into it, and it looks something like this. Connor is a very fun person, so he put an image of himself on my desktop, something called Connor's special build, and he said, go try this build for this blocking problem. I'm like, okay. Well, one of my problems is too many locks. So I look over at Management Studio, and I've got a query with like 10 million transactions. But for 10 million transactions, if you go look at some lock data, I need 10 million locks. The server almost tips over because of this. Well, Connor's like, try my build. I'm like, try your build, what is it doing? So he's like, okay, well, go over here and run the same set of queries with 10 million rows on my special build and see what you get. So I ran this query, I went back and looked at the locks, and there's one lock. I'm like, what is this exact lock thing? He's like, it gets better, Bob. I know you had a blocking problem because of something called lock escalation. I'm like, yes, I'm updating two halves of the table in transactions, and they're blocking each other. So I'm running these queries here, and I'm like, yeah, here's one that's run, here's one that's blocked. And if you go look at what we call blocking information, like our diagnostics, you can see here it's a lock escalation. So they're blocking each other, even though they're only updating each half of the table. So Connor's like, okay, try my special build. Well, what is your special build going to do? It's not going to solve this. He said it is. So I'll run one update here. That finishes. I'll run an update for the other one, and it finishes too. And I'm like, what is happening here? So I went and looked at the lock diagnostics. I'm looking right here. I can see it. And sure enough, there's only a couple of locks. I turned to Connor. I'm on a meeting with him. I'm like, what is an exact locked? He's like, Bob, what you showed for DOP feedback is amazing because it's innovation that's in the product today. But we don't just stop there. The query processor and the database engine for SQL, running edge to cloud, is a very important technology. So we're always innovating. So while this is not available today, it's just giving you a peek into the future of how we're trying to solve problems for developers and our customers with no code changes. So that's all impressive. Connor and I are in this meeting together talking, and our other colleague, Lindsay Allen, happened to be in the same meeting. She's listening to all this. She's like, I can beat you as well. We're like, what are you talking about? She goes like, well, I have a technology called Copilot for SQL. I'm like, Copilot for SQL? We know how to write SQL. She goes, but not everybody knows how to write most efficient SQL. So she shows us something like this. In Visual Studio Code, she goes in and she says, look, see that icon down at the bottom down there? This is something called Copilot, running along with a developer to look at their language, their programming language. So she said, okay, well, here are the different types of language that we can do for Copilot. I'm still not getting the Copilot thing. I'm like, I don't understand what this is really doing, but I'm a SQL person. She goes, oh, we got SQL. Well, what can it do? So she said, well, we'll type in some comments into Visual Studio Code, and it's going to actually generate the SQL query needed for it. Like, what version are you using? I'm like, well, I know what version I'm using, yeah, but not everybody knows how to write the query for that. Who can remember the functions for it? So it's select that version. Okay, well, Copilot said to do that. We'll go run on here, and sure enough, Lindsay showed us the result, and it's SQL 2022. And I said, Lindsay, that's kind of pretty basic. Like, a lot of people know how to do that. She goes, okay, fine. I'll write a query for what tables are in the database. And I'm like, well, everybody knows that. No, and everybody knows, Bob, the system table names like you do. So she said, I'll use the database, and I'll tell Copilot, generate a query to get me all the table names. And Copilot just generates this query automatically. And I'm like, Lindsay, this is pretty basic stuff. Like, I need something more impressive. And she's like, all right, well, what do you struggle with? Well, developers struggle with writing queries that are called sargable. queries that make sure they efficiently go after an index. She said, okay, well, here's an example. I'll go find out a typical query by telling Copilot in English, here's the kind of things I need from the database. But I need Copilot to write it efficiently. So it tries to generate this first, and Lindsay said, well, I don't know if it knows about Sargable, but we'll try it. So it says, okay, hey, Copilot, use a Sargable query to make sure we write it in a way that it efficiently retrieves the index. So she typed this in here. I'm like, Lindsay, I'm still not impressed. And she says, okay, Copilot, what is a Sargable query? This is actually so impressive. She wrote this thing, and she's doing this in the meeting on the fly. And I'm like, oh, what is this thing? And it turns out that Copilot says, oh, yeah, it's how to write a query that knows how to go after efficiently an index. And I'm like, well, I'm still not impressed. Where's the query? So she hits the button here, and all of a sudden, what translated before for a query turns out to be a query that is efficiently written to retrieve an index. So she hits here, she goes forward, and I'm like, look, and boom. And I'm like, well, that is a Sargable query, but I don't believe it's really using the index. She goes, fine. How do I prove it to you? I said, well, go look at the plan. So she says, fine. So she turns on show plan, a command in SQL to show the actual plan. She runs the query and goes over to the right and says, okay, well, Bob, how about that? It's using an index seek. Do you realize how many developers and how many people struggle to write T-SQL that efficiently goes after things like indexes just because of the nature of how they wrote the query? That is the power of something like Copilot can provide to developers and SQL Server professionals. So DLP feedback, if you think about what we showed there, we showed a new locking model to solve common blocking problems and a technology like Copilot. We're really trying to bring innovation to our products, SQL Edge to Cloud, SQL Server 2022, and even in Azure SQL, again, getting you faster with no code changes. So another thing that Rohan showed you and talked about is new developer experiences for Azure SQL Database. I have been doing development for SQL for 29 years. And when Drew showed me some of the things that we're doing in this space, I'm like, this is no longer your grandpa's SQL. I don't know if he meant me as the grandpa part, but certainly he talked about that SQL technology for developers has come into a very modern age. So I'd like to bring Drew Squires-Cabal on stage to show us what this looks like. Hey, Drew, how's it going?
Hey, it's good.
Yeah,
Thanks, Bob.
Yeah, thanks for coming on, man.
I'm super excited to show these new features, but I built my demo on my Mac. And
I know, but you have the Mac, right?
I thought you had it.
I don't have the Mac. You have the Mac? What are we going to do?
All right. Thank you. Yeah.
Drew, once again, Marisa saves the day for you. Good luck.
Every time. All right. Well, folks, I'm going to talk about some of the developer experiences and features that are available for Azure SQL Database. And like many developers, we've got a to-do list. We've got stuff to get done. First, we're going to need to make sure that our development environment is set up, but we're going to do that in a way that we know that other people on our team can also then use it. There's a mobile app team that's trying to implement mobile ordering, and they need some APIs, so we need to get those out to them as soon as we possibly can. When we ship our products here at AdventureWorks, we want to be able to notify our customers, so we're going to add customer notifications. And if that's not already enough, there's a brand loyalty program that needs to track customer points, and we need to set up those APIs and ensure that that database is going to be completely auditable. So let's dive right in. So from our current production database, we're going to take that database schema and we're going to bring it into a SQL project. What a SQL project is, we're here in Azure Data Studio. We could do this from VS Code as well. But what this SQL project is it's a copy of the files that represent our database schema. So all of those objects that tables, stored procedures, we're bringing them into files that can be tracked in source control. With these files in source control, we can integrate with GitHub Actions, so we can kind of do that whole CI/CD thing that's great. But we're also able to, in local development, build and validate that schema. That's great, but when we start building actual apps, we need a database locally. By publishing our project locally, we can stand up the new Azure SQL Local Development Container. For free, using Docker containers, I'm creating an Azure SQL database locally with just a few prompts, like which version of the emulator do I need, light or full? And then it's going to go ahead and kick off setting up a local development environment. Because this is all based on SQL projects that are in source control, the rest of my team can go ahead and also pull down that repository, get started in exactly the same way. I'm doing it from my Mac. They could be on Windows, they could be on Linux, and we can all use Azure SQL Database together for our development. This is standing up the container. And now it's building and deploying the SQL project schema to the database. We know what the table structure of our production environment looks like, so we know what to expect when we go ahead and connect to our local host. So once it's done, we can make sure that our local host connection works, because we're going to need that if we're going to start building APIs for our mobile app team. All right. So this has taken us a few seconds here to get rolling with our local development environment, but like I mentioned, it's now very reusable for the rest of our team, and because it's going into source control, maybe we're pushing to Azure DevOps or GitHub, then we can deploy database changes that way. So how about setting up a bunch of APIs? I'd like to introduce you to the Data API Builder. This is a service-based tool that we can use to configure APIs just with a configuration file. So I can initialize it for a development environment by giving it the database type and the connection string. This is giving us that dabconfig.json file. The ease of use here is that I can set up a product endpoint, and the source is the table saleslt.product. I'm going to set anonymous permissions. There's extensive configuration capabilities, but we want to get the draft of these APIs over to our mobile ordering team really quickly. So now all I need to do is dab start, and I'm going to get a localhost port 5000 and then secure 5001 that we can start testing some operations against our product table, like get or post to query and then add new products. So we've got columns in the product table like product number, color, size. But what we want to do is see how they work. If I run that GET request against local 5001, I've already got a working API. It's kind of simple, I know. Bear with me. With extra query string options, we can do more advanced things like changing the columns that are being returned, or maybe just limit ourselves to 10 rows. Now that, I probably have the query string wrong, just a second. Yeah, first, my bad. Okay, so now we're limited now to just 10 responses from this. Now, REST is really cool, but how about GraphQL? I mean, that is the newest bee's knees for developers, right? So if I want just the black products, name, product number, and list price, I'm able to send through that GraphQL query as well. All of this through Data API Builder. We've got that done. We can check that configuration in and we're done. But I need to move on to sending notifications on order shipments. We can call a SignalR endpoint, but really we can call any endpoint. We could be integrating with Power Apps or another Azure REST endpoint. I'm using this stored procedure within my SQL project, and I'm adding both a query to set up a payload using JSON capabilities, and then the SP invoke external REST endpoint. And it's calling that URL SignalR endpoint. I can build the SQL project locally just to make sure that my syntax is okay. And then we would check this into source control and it would deploy right there. So that is all we need to do to call a REST endpoint from Azure SQL Database. Last but not least, that whole customer loyalty program, we need a table with a points awarded column, and we want it to be auditable, so we're going to enable Ledger. And the great news is with Ledger, configuration is literally saying with Ledger on. That's it. We're ready to use Ledger, to use blockchain, to keep the auditability trail of our database. So with this table, I want to use Azure Functions. I love Azure Functions. But now with SQL bindings, the input and output and trigger, I reduce a ton of boilerplate code. I can write this SQL query for an input binding, and that means that I've got a query and I can say, hey, I want all of the points that have been awarded. Now with the loyalty points as they're awarded, it means that they add to the table the customer order details. So we got input and output. This one here is going to use that POCO to write into that customer order details table. So let's show that really quick, because I'm going to run out of time. I have so many features. Oh. With the points awarded post, I'm going to add 200 points to the sales order 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we go. And now I'm going to change it to 8, 8 on the end real quick and say just 100 points for that sales order. So we've put in a total of 300 points for the manufacturer ID 1. And if I get that sum, oh, wrong query string again, that is my trend today. There we go, manufacturer ID 1, 300 points in there right now for manufacturer ID 1. That is how quick we are moving and building APIs. Now, if I send that post again, it's an upsert operation based on the primary key. So since I didn't change the primary key, it didn't add another row, we still only have 300 points. This has been cool, but I only mentioned Ledger briefly, and I've got to show you how great Ledger is for ensuring auditability. So I built another API endpoint that's calling a stored procedure through the SQL binding, and that stored procedure calls a number of stored procedures to check the Ledger digest. This is going to validate that blockchain to make sure that this database has not been tampered with. My DBAs, anyone else in the company doesn't have access to do that, and so I can send a request now just to verify that last block. Well, with this, just a reminder, not only queries, but stored procedures can be called from these input and output bindings. And what I didn't demo today for Azure Functions is the trigger, where you can call a function based on changes to a table. All right, that was a lot. That was fun. I mean, setting up the development environment people can use, that was our local development container. Using the data API builder, and now the Azure SQL Database SP Invoke External REST endpoint. Last but not least, all of those integrations for Azure Functions that reduce the boilerplate code. Bob, it's a lot of fun to get that done.
Drew, this is a long ways from the days of me writing DB library code with SQL Server a long time ago, so I love this stuff. You know, if I'm a developer in this audience right now, and I'm like at a startup though, I need to think, and SQL is kind of perceived as like an expensive product in my mind to a lot of people, but like if I'm a startup and developer, like how do I get this stuff at a lower cost or even free?
So for developers, getting started is free. The local development container, that is free. SQL Server Developer Edition is free to use. A lot of these tools, like the Data API Builder, that's going to be released into open source code. The Azure Function SQL Bindings code is open source. There's a lot of new things.
Great, Drew. Thanks so much for showing those developer experiences. Appreciate it.
Thanks,
Glad
Bob.
you found your Mac.
Yeah, oh gosh.
So to kind of put it all together at the very end here, let's look at an example of how the Microsoft Cloud, how the Microsoft Intelligent Data Platform can be brought together for actual real-world scenarios. So I'd like to bring on stage my friend and colleague, Buck Woody, to kind of show this in action.
Hey, Bob.
How's it going?
I'm going great, man. Hey, hold on 1 minute. Will you take this to Charlie?
Oh, sorry. Okay, yes. I'm known for just doing water for people.
Yeah,
Thanks, Buck. Appreciate it.
Hi, everybody. I'm Buck Woody. I'm the real BW. We're here to talk about the Intelligent Data Platform a little bit. We've seen a lot of stuff today, a whole bunch of different products. But let's take a simple question by a salesperson. You ready? You probably had something like this. You know, with our supply chain issues and all that, what I want to do is before I sell something, I need to make sure we have the parts that we can actually build it. Can you just make me a button? I mean, just query a database or something. Can you just make me a button? And every developer in here just went, oh, no. And all the data professionals, same thing. Oh, because we know it's not simple, right? It is a simple request, and it's a fair one. But it's not a simple thing to do. The data's here, it's there, it's in different formats, it's relational, it's NoSQL, it's text files, it's all over the place, even in Office. And it's hard to get this data. Well, let me switch to my demo machine here, not a Mac. Sorry. Most companies want you to move all your data to their systems, right? Just export everything, rewrite all your code into our system, and you can answer that question simply, easy, right? So of course we want to do that. But at Microsoft, we want you to be able to use the best-of-breed software that you already know and you're already using. SQL Server or Postgres, you can see here, Synapse, Power BI, and so on. But you need for it to work together, all together, with tools you already know as well. So let's take a look at a real-world example of what we're going to do here. So hold on a minute. I've got AdventureWorks. They have upstream and downstream partners, and they're using SQL Server and on-premises and SQL DB, and you can see they're using it here for sales, products, and partners. You can see the queries I've got going here. It just kind of has all their data in it. And you can see they've got a partner here called Contoso, and of course Contoso is going to use Postgres, they use something else, and they add some enrichment to the data, such as like changing the product models. You can see a catalog description. This is, you know, what they resell from that. Now that catalog is stored on the web storefront, and of course the dev team there is using Cosmos DB NoSQL for that. since it's got different consistency needs and so on. They use notebooks for the data and visualizations. All right, so how do we combine all this together? Let's stick with that best-of-breed software that we already have and use the intelligent data platform to integrate everything together. Let me pop over here to Azure Synapse, and I'll start the integration there. You can see I have a Synapse Analytic workspace, and that allows me to have lots of kinds of data that I can work with. I've got SQL serverless access, I've got Spark pools you can see here, I've got other kind of pools of data that I can use. You can see I've got that set up already here in the data area. Now, as I develop, you can collaborate using a code repository in GitHub. Now, I can also work with Synapse Live to work with others. You could store the data in Azure Synapse, and you can link data from SQL Server, from both on-premises and in Azure SQL DB into Synapse, so you're querying the same data in both places. Let's take a quick look at this. Now, I've already set the link up from AdventureWorks to Synapse, and you'll see I've set the connection to send some of the data and keep that replicated over here in Synapse in real time. You can see that connection right there. Now let's take a look at that data in Azure SQL DB. Let me pop over to that. I'll run a query over here inside Azure SQL DB. It shows a couple of locations of a product that we've got and the quantity that we have available. Now, can we see that data over in Synapse since it's supposedly replicated? And it turns out you actually can. Hold on. Let me run just this part of a script, and it should have the same locations and quantity, fingers crossed, that we saw in Azure SQL DB. Yep, okay, good. That's always positive. We noticed that product 751 at location 60 has a quantity of, 105? So let's go back and make a change in SQL DB's inventory. You can see that we have product 751 at location 50 in a quantity of 105. So let's go and sell one. Let's go back over here to SQL DB, and we've got that stuff. You can see the data here, so that looks the same so far. So now we'll update it. Let's sell one. Should be now product 751 and location 60 should have a quantity of 104. Is that right? Is my math good? Subtract one there. I can usually do that pretty well. All right, and it comes back, and sure enough, here we go. Do I have 104? I do. Okay, so I have 104 in SQL DB. Now this is great. Now let's go in, pop back over here into Synapse. We had 105, remember that? Now we should be able to query that same data. Let me run just that one, and I'll run just this query here. Hold on just a sec. Let me highlight that. There's the 105. Highlight this and run. Where is it? There it is. All right, drum roll. We got it, 104. So that replicated just that fast to do that. Now this is all great, but wait a minute. What about that Postgres data we talked about, right, that our partner has? Can we bring that in? Well, we can. We've already seen the linked connection for our SQL Server, but I've got the linking details. Let me show you that real quick. So there's a linking table for that. But we also have pipelines that we can use. And yes, this might look familiar to you because this is actually Azure Data Factory. Remember, this is the best of breed thing I was talking about earlier. Now recall that Contoso had data in Postgres. So we've connected to Postgres, to that source, and I can use a query or a full table, and I can get that data, and then I can put it somewhere. Recall those Spark pools I mentioned a moment ago? We'll send the data to storage that always stays on Azure Data Lake, and you can see the Postgres data that was piped in, just so you can see where it landed. Let's go take a look. So this is my storage here, so that's where it landed. You can see it right there, and that's the blob that it's in inside the data lake. Let me go back to my Synapse Workspace link and take a look. Now we can do some more customizing in here. We can map the tables in a new way. I can dynamically find out what columns are there because we're using Parquet, right? So it's got structure. This page has other settings you can change. We can change things like user properties and other things. All right, so let's go back to our data sets here. And here you'll see the external tables that have been set up to allow you to query using SQL syntax, but from Parquet files right inside the Synapse portal. We can connect that here. Here we go. Let me get that up. Parquet files. This is what's amazing to me. I'm typing something that is I'm not having to write MapReduce or any of that thing. I can just use regular old SQL statements to get this data. Now, remember, we asked a pretty simple question earlier. We said, can we get the data in this place? My salesperson just wants a button. Now, I'm not a Power BI person, but I did toss together a little visualization here that shows the answer. I'm kind of proud. So let's, we could do this right inside the portal, by the way, but I use Power BI Desktop because I'm going to put it on a phone. I'm not going to write code. I'm just going to give them a report. We can connect to the data sets from Synapse, and we've got access to all of those here. For location 10, let's say it's in Tampa, we can find all the quantities of the things we want. Now, you're probably better at BI than I am. You could deploy this directly to the phone, or our salesperson can check on a website the supplier status. Now, wait a minute, the web dev part of the team is using Cosmos DB NoSQL. Can we go get that data? Let's go over here. Yeah, there is. We can enable a Synapse link in Cosmos DB played in the portal, so you can get it from there. But there's more. You know, there's a lot of folks in the organization that seem to be using Office 365. Folks have people using that, and other parts of the Power Platform. Have you heard of this? And even data outside of Microsoft, I know, right? Like in Google Sheets and other kinds of things like that. I want that data too. Can I get it? Yeah, inside the Power Apps portal now, you can see a new section here called the Dataverse. And inside Dataverse are connections to all sorts of business data, including those Google Sheets and so on. And yes, I can set that up to go to my Azure Synapse link and go right back. All right, so I've got my report, I've got all my tools, I've got my Dataverse, I've got my platforms that I'm using, and I didn't have to export anything or completely rewrite my system to make this happen. I'm able to do this quickly with the Intelligent Data Platform. One final thing, you can also use Microsoft Purview that Rohan talked about earlier to govern and find and query all these data sources. Is that cool or what?
Well, Buck, I was really impressed. I was watching that back there.
Yeah.
I'd really not seen this before. Buck, that is the worst Power BI report in history.
All right. Well,
I think I need to call the guy in the cube the next time to actually get that
I'm no
better.
Patrick LeBlanc.
You're no
Let's
Patrick
just-
LeBlanc. That's obvious, right?
Yeah.
But Buck, the technology is pretty impressive. You know, I'm a database guy, so I got how you're linking all these database systems together. Dataverse?
Yeah.
What the heck?
Yeah.
What
is that crazy or what? So all of the things that you're using in Office, Dynamics, all kinds of, all that stuff, and things that are not inside Office.
You mean M365?
Sure.
I think there's somebody here in the audience that actually cares about that
There's
technology.
probably folks that know M365 here today, but you can get all that data, Bob. We didn't even show the AI reports, the things we can do with that data once we get it, and we didn't have to we've made a new thing, just put all your stuff in here.
Awesome. Thanks, Buck.
No
Great
worries.
demonstration. Appreciate it. Thank you. Well, I hope you saw what was possible with the Microsoft Intelligent Data Platform. Hey, in our team, data is everything. We know that you need data at the right time and the right place and on the innovation and the speed of innovation on your terms. Thanks, everybody. Hope you enjoy the rest of the conference.